So in this problem, we have an aircraft heading east with a constant speed of 100 meters per second, and we have to model the system and see what happens to it. So initially it's heading east with a speed of 100 meters per second. Now it says a wind with a constant velocity of 20 meters per second blows southwest. That's southwest there. Each of those angles is 45, 45, with the total being 90. So each one of these has 90, with the ones in between, southwest, southeast, northeast, is all 45 degrees. So in this case, we're looking for this vector here, southwest. So the wind is going southwest, like that. So that angle there is going to be 45, as we established, and the speed is 20. So the resultant velocity is going to be like this, in this direction. So basically the plane was heading this way, the wind came and pushed it, so it starts heading that way. The resultant velocity is always from the beginning to the last one you did. Remember, like this, and then it's like this. So we call this V. Now, what we need to do is find this new speed that the aircraft travels at, and then we have to find the angle that the aircraft would have to rotate in order to go back to its original destination. So first of all, let's find the resultant velocity. And the easiest way to do this is by using the cosine rule. Now, this is the cosine rule here. It's going to be v squared is equal to one of the other sides squared plus the other side squared minus 2 multiplied by those two sides again, 120, multiplied by cosine of the angle opposite to this here. So that's V, opposite it is cosine 45. Plug all these numbers in, don't forget to square root, and in the end you'll get a value of 87 meters per second. So the aircraft slowed down because of this wind interference, and you can see why. It's quite an aggressive angle opposing it, so it's going to slow it down. Now to find this angle, we use the other rule of triangles that are not right angle triangles, which is the sine rule. And the sine rule says that sine of any angle in this triangle, so for example let's take sine 45, divide by the opposite side, which is V, which we just found here, 87, is equal to any other angle. Now we want this angle, so let's make it sine alpha. Sine alpha divided by the angle, the side opposite that angle. So it's going to be 20. Now, all you do now is find this, it's one number, cross multiply or multiply both sides by 20, so 20 goes up here, inverse sine alpha, and you find that alpha is equal to 9.35 degrees, which is the angle needed for the aircraft to go back to east.